track over here. Here's all my y values. So my sign is going to go 0, then a 1, then a 0, then a -1, and a 0. This is going to be all 4 quadrants. Remember, you have 4 quadrants to go through. And because our circle is 2 pi, or 360, every quadrant right now is 90 degrees until we change the period. Because we're going to get 1 complete cycle in 2 pi. So let's break this guy down. I have these take all my different colors. So we'll do these all in different colors. Now, here's your basic sine curve. What is the amplitude for your basic sine curve? What is its period? 2 pi. What is its frequency? 1. At first, somehow, I always thought they should have swapped those 2 around because we know this is 2 pi over b, and this is your b. So now, let's graph this. Now watch. Half of your quadrants, when it's 0 radians or 0 degrees, this sign is 0. When it's 90, it is 1. When it's 180, it is 0. Just follow your quadrants. Follow this pattern to -1 to 1. Remember, it's a continuous curve. Okay, now let's take a look at what happens here. What does that 0.5 do outside of the sine word? Makes what smaller? My amplitude. Good. That's where A is. A is always measured absolute value. So my amplitude is now 1/2, or 0.5. Did it change the period or the frequency? No. So I'm still 2 pi. I'm still 1. Now watch what we're going to do. We're going to take this standard row, and we're going to multiply everything by 1/2, or 0.5. Because that's what we need to change, is how high and how low it goes. So this becomes 0, 0.5, 0, -0.5, 0. We're going to graph right off of this thing right here. Did we change our period or frequency? So every 90 degrees, this should be still happening. So instead of that, now we go 0, 0.5, 0, -0.5, 0. Okay? Actually, probably a little less. Good. So all we did was change our amplitude. They call this guy the midline right here. This is their midline where y is equal to 0. I usually call it the resting line. But they call it a midline, whatever you like to call it. Now the last one is my amplitude is now a 3. Okay, but let me step back a little bit. I'm sorry. Let me just step back a second. When we change this, God bless you. God bless you. When we change this amplitude to 0.5, how did this affect? What do we call this transformation? A shrink, vertical. So this guy was a vertical shrink. Shrink by a factor of 1/2. We might as well just add all this stuff in here now. It makes more sense. Now I'm changing this guy to a 3. So my amplitude is going to a 3. Is it changing my period or my frequency? So I'm still using the same setup. I'm still going every 90 degrees. Now I'm going to take this and I'm going to multiply everybody by 3. So I get 0, 3, 0, -3, 0. And that's what I follow. 0, 3, 0. Oops. -3. Oh, darn. I don't want to lose this. I think I just did. There it is. I can't reach that last point, but it's down there. 0. So it's going like this. It changed the amplitude on me. So what did we call this? A vertical stretch. Good. By a factor of 3. This is a vertical stretch by a factor of 3. Now, I'm going to take one of these and put this in your calculator. The key point here is where your radians are, where your quadrants are. So everybody put your mode in radians. Everybody get your mode in radians. The first thing we're going to graph is just a plain old sine curve. Sine of x. See if it's cooperative today. Then underneath it, I'm just going to graph the 3. Because the 0.5 and the 3, they'll work the same way. I'm just going to graph 3 sine x. Okay, now, before we do anything else, let's go to our window. Oh, actually, do a zoom 7 first, if you don't mind. A zoom 7 is your zoom tree. It's going to pick up the fact that we put radians in there. So yours looks like this, right? Your graphs look like this. However, your table doesn't look like this. Your table looks like this. So we have to make your table look like our graph. So if you notice in your window, this is real close to negative 2 pi because pi is 3.14, like 3. So that's negative 6, positive 6. Your scale right now is pi over 2. 3.14 divided by 2 is 1.57. Every 90 degrees. Aren't we making another piece every 90 degrees? We didn't change the period. We took 360 or 2 pi and divided it by 4 quadrants, every 90 degrees. This scale is what your table set has to match. So now when you go to your table set, stay with me because this makes life a lot easier. Make your table set how big your quadrant is. But we're in radians. So pi, let's make my pi, over 2. Okay, now when I look at it, it's still in radians, yes, but every increment here matches the increment on my graph. See your patterns out here? They're right there with us. So even though this isn't decimal, because your calculator can't put the pi sign there, it just multiplies it by 3.14. We can still follow it. There's the 0, there's the next increment, the next, the next, the next. Because we made your table match your graph increment. That's key to the whole graphing calculator thing. Sure. We need to change your table to match your graph. Your window, your x scale, and your changing table has to match the size of your quadrant. So right now, our period we said is 2 pi, right? So isn't our quadrants every 90 degrees? And I could put this in degrees. If I wanted to, I could put this in degrees. I happen to like radians, but I could put this in degrees. Now, you're going to have to redo your zoom 7, and we're going to have to redo your table. So now your table set has to say, maybe this will make a little bit more sense to you. This is like negative 360 to positive 360. There's your x scale. So now your table set has to say, start at the 0 and go every 90 degrees, because that's my quadrants right now. Does that make better sense right now? Putting it in degrees right now? Yeah. Okay, but realize, isn't it still giving me the same tick marks that I have on my graph? I mindlessly just have to look at it. This next one, this next one, this next one. I make it match my graph because my x scale is going to make my delta table be the same. Okay, now here's where we get into a little bit of a problem. We have to slightly change your cosine. The period of your cosine is going to change. So now, right now, it's the b that's going to change. There's a basic cosine curve. You're still at your midline. Your basic cosine curve says amplitude of 1, frequency of 1, period of 2 pi over b. So that's 2 pi, sorry. 2 pi. Now, your cosines are all your x values. So let's make a pattern. 1, 0, negative 1, 0, 1. Stay with me. This is the easiest way to graph. So we start here. Instead of starting at the 0, we're starting at the 1, then the 0, then the negative 1, then the 0, then the 1. Didn't we go every 90 degrees every quadrant? So here's my original cosine curve. Okay. Now, we get to this guy, and this says, uh-oh, your amplitude is still 1, but your frequency changed to 2. Now think this out. If I put two curves in 360, how long is it going to take me to get one curve? Pi, and in degrees, 180, right? So sometimes in degrees it's easier to think about. If I have two curves in 360, well, one curve will take me half of that, 180. My period is 2 pi over b. 2 pi over 2, half. So if I put this in here, 2 pi over 2, I get every pi. Okay, now, stay with me a second. Every pi, come knock this off right here. Halfway through, I have to have completed one curve, and then I got to complete the other curve. How many quadrants do I have to walk through? 4. I have to take this and break it into 4 equal quadrants. If this is 180 divided by 4, every 45. But easier way is just eyeball this. This is half, this is half, this is half, right? Do you have 4 equal ones? Same thing here. This is half, half, half. It's at every 45 degrees. So watch, my same pattern. 1, 0, negative 1, 0, 1. There's my first one. Isn't that one cycle in pi? Or 180 degrees, right? I do it again. 1, 0, negative 1, 0, 1. So do I have 2 complete cycles in 2 pi? Now, watch what happens when I put this in my calculator. First of all, I'm going to change this to cosine. And my second one, I'm going to say, what was it, 2? Cosine 2x, right? Cosine 2x. I left this in degrees, so we're just going to graph. Here's my cosine curve. Here's my second one. Looks all well and good. Now, watch up here a second. I need to get this to my paper. So, I look at my table and I say, okay, here's my table. This one's all well and good. This was my regular cosine pattern, but look at this guy. I have no zeros in here. This one's going to have a problem because I changed the period. So now, go back here, change your x scale. Your period was 180, right? How many quadrants do you have to go through in 180? How many quadrants in a full circle? 4. So every 180 I have to do 4. So what's 180 divided by 4? 45. So watch. If I change this scale to 45, here's my window. My window changes. My graph changes. See all the extra tick marks? Now it's hitting those tick marks, but I didn't change my table yet. So now I got to go to table set, and I got to make my delta table the same as my scale. So I come down here, and instead of 90, I got to make this say 45. My scale and my table have to say how big each quadrant is, or you're not going to be able to read it off your table. Now, don't I get all those here? This is the guy I'm looking at, because we already did the regular one. Isn't all my patterns right there now? If I needed it to be? Okay? It's a little bit more involved in the calculator, but all you have to remember is your scale and your delta table have to be how big your quadrants are. That's all you have to remember. Now, we're changing this. My amplitude is still 1. My frequency now is 0.5. That means I'm going to do half of my curve in 360, or 2 pi. So if it takes me half of my curve in 2 pi, how much will it take me to make a complete curve? 4 pi. Good. And isn't this 2 pi over 1/2? Keep, change, flip. 4 pi. So doesn't that make sense? So now, think about this. 4 pi to complete one cycle. I have how many quadrants in a circle? 4. So how big is each quadrant? 4 pi divided by 4 is how much? Every pi. So here's my cycle. I'm starting at the 0. It's 1. Then I go to pi. Right here. It's 0. Then I go to 2 pi. There it is. There's my half of a cycle in 2 pi. Do you see how we changed the quadrants? Because now I have 4 pi to make one cycle. I still have to go through 4 quadrants. So now instead of every quadrant being 90, it's doubled it, didn't it? Every quadrant is now 180. But I'm still walking through my cycle. 1, 0, negative 1, 0, 1. Does it make more sense? I probably should have done this yesterday rather than go through all the separate parts with you. I think we spent so much time going over the homework. The homework was difficult. But I probably should have just concentrated on the basic parts. You ready to move on? Mm-hmm. Okay. All right, I'm not worried about that part. Okay, now. Good, now, this guy, notice where all your parts are. They're over here. What kind of transformation are we getting? Shift. Which way? Up or down? So what do we call that? Vertical. These are giving us vertical shifts. And we're working off of a sine curve. What's my pattern for sine? Okay, just make a little unit circle. Follow those y values. And now my midline is going to change. My midline has to change now because that's the guy we're shifting. So for the first one, what's my amplitude? Well, what's my amplitude on all of these? 1. What's my period on all of these? They didn't change this, luckily. They only changed the vertical shift at the same time. Okay, so now, we took your sine curve and we moved everybody up 1. So, watch how we're going to do this. We're going to come over here and we're going to add 1 to all these parts. We don't really care. We'll just add 1 and then we'll follow the new pattern. This becomes 1. What does this become? 2, then 1, add 1, 0, 1. All we have to do is follow this. Watch. 1, 2, 1, 0, 1. Isn't this my sine curve shifted up 1? That's all we have to do. We don't even have to think about it. We just take our pattern and we apply that transformation to our cycles. Now, your midline went from here, this was my midline, to here. Isn't this now my resting line? This is where you see your transformation best, from here to here. So what is my midline out now? What would the equation be of that horizontal line? Y equals 1. Good. Because we said y was equal to 0, but we added 1. So is it my midline now, y equals 1? Right? Wasn't it before at my x-axis? What was it, my y equals 0 line? These do make sense. So now, let's do this and do a vertical shift down 1. Start with this and subtract 1 from everybody. This becomes negative 1. Then this becomes 0. Then this becomes negative 1. Then what does this one become? Negative 2. Then negative 1. So let's see what happens. It kind of looks a little strange, but let's see what happens to it. So I start at negative 1. Then I go to 0. Then I go to negative 1. Then I go to negative 2. Then I come back up to negative 1. So did I shift everything down 1? Look at my resting line. My resting line is here. Isn't this a vertical shift down 1? And you see your sine curve? It looks a little bit weird doing this, but isn't this a whole lot easier? So now, if my midline was y equals 0 and I subtracted 1, my midline is y equals negative 1. Make sense? Okay. Now, for the last one, where is that going to go? Where's this guy going to go? 1/2 up. So we're going to take this 0, 1, 0, negative 1, 0, and we're going to add 1/2. 1/2. 1 plus 1/2 is 3/2. 1/2. What's 1/2 plus a negative 1? Negative 1/2. 1/2. And look how weird that looks. But we can still do this. So watch. At the 0, you're 1/2. Then you're 3/2, which is 1.5. Then you're back to 1/2. Then you're negative 1/2. Then you're back to 1/2. And where's my resting line? Right here, isn't it? Didn't my resting line go from here to here? So I was y equals 0, and I added 1/2. So now my resting line is at y equals 1/2. Good? You feeling those cycles? And any questions? Yes.
How do you know when it's a horizontal shift?
A horizontal shift is when it comes in between the x, when it's like next to the x. We call that a phase shift. We looked at a small one yesterday, like x minus pi over 4, when it goes like this. Because weren't your horizontal shifts like these guys when it was next to the x? So when it's next to the x, that's, in trig, we call it a phase shift. It's the same as a horizontal shift.
Could those be mistaken as a horizontal?
No, because you're outside of your x. Especially like if you put this in your calculator. When you go to put this in your calculator, where are you going to put your parentheses? You're going to put your parentheses around the x. See the x parentheses? And then you're going to say plus 1.
Okay.
Your phase shift, you're going to keep it inside. Just like you do with your squaring.
So if we get a horizontal one, it will already be in the
Will be in the parentheses.
parentheses?
And we looked at a very small one the other day, just like x minus pi or x minus pi over 2, whatever we looked at. It's a horizontal shift, but in trig we call it a phase shift. Because it actually, even though your curves are endless, it actually changes where we start the curve. Carlos, did you have a question? Yes. Okay, so now, last one. Let's get rid of some of this ink over here. Putting some more space. We've got a whole bunch of things going on now. Let's do one at a time here. We've got a cosine curve. So, what's your cosine pattern? 1, 0, negative 1, 0, 1. Know those patterns. What's happening to my amplitude? It's shrinking. It's now 0.5. What's my frequency? 3. My frequency is the B guy. This tells me I have 3 complete cycles in 2 pi. Or, listen carefully, 3 complete cycles in 360. Therefore, how long does it take to make 1?
2 pi over 3.
2 pi over 3, and what is that in degrees? 120. Every 120 degrees. And just like Monet just said, 2 pi over 3, and we're going to put 120 over here. Now, here's the key. Every 120 degrees, I need to make a cycle. How many quadrants do I have to go through for one cycle? 4. So I'm going to take this, and I'm going to do 120 divided by 4. Every quadrant has to be 30 degrees. Every time I go through a 1, 0, 1, negative 1, blah, 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 I have to go through at 30 degrees. So we're going to make all our tick marks match 30 degrees. So watch. How many 30s inside my 90? 3. So I can start like this. 30, 60, 90. 30, 60, 90. 30, 60, 90. 30, 60, 90. I just separated them into 30 degrees. So each 90 has 2 tick marks inside of it, which gives you 3 sections of 30. This is what was key right here. That in that 120 degrees, we have to do 4 quadrants worth. So now, watch. Here's my 120. 30, 60, 90, 120. There's my 4 quadrants. 1, 2, 3, 4. 1, 2, 3, 4. I really don't have to think about it too much. And now, I take this thing, my routine. The only thing that's changing that is my amplitude. I multiply everybody by 0.5. I get 0.5, 0, negative 0.5, 0, 0.5. There's my pattern. And I got to follow it every 30 degrees. So, at the 1, I would normally start my cosine at the 1. I have to start it at the 0.5, right here. Then 0. Then 0.5. Then 0. Then 0.5. This is one cycle. Like a tiny little bit off because I'm sideways here. So then 0.5. Then 0. Then negative 0.5. Then 0.5. See it? There's my second one. Whoops. 0, 0.5. Sorry. Then my third one. 0. Oh, sorry. 0.5. 0. Negative 0.5. 0. 0.5. See it? 3 cycles in 2 pi. My amplitude is 0.5. Did my midline change? Nope. What causes my midline to change? A vertical shift. Otherwise, my midline is still y equals 0. Yes? Okay, so everybody's good with this? Okay. Now I get the joy of erasing mine, and then we're going to do the sine one. As a matter of fact, can I skip the sine one and do the cosine one over here first? Because we can put that right on your graph. So I'm going to jump down to 3. What's the amplitude on 3? 2. What's the frequency on number 3? 1. So therefore, what's the period? 2 pi. So how big is our quadrants when we're in a 2 pi? Every 90. So we're back to doing the 90. So I'm just going to make these a little darker so we can see them. The only thing that I have to worry about is my amplitude. So I take my pattern, 1, 0, negative 1, 0, 1, and I multiply it by 2. 2, 0, negative 2, 0, 2. Back on the 90s, not the 3, 6, not the 30s. So I start with 2, 0, negative 2, 0, 2. That's good, right? We're still, what's our midline? Y equals 0. Oops, oh, I'm sorry. I missed the whole, my fault there. You didn't tell me to stop. Okay, let's move this out of the way completely. How's that? We forgot this guy. I'm sorry. I forgot that guy. So now, watch. So that I don't have to think mindlessly about this, I'm going to add 1 now to all of these guys. Because I need to take wherever they are and just move them all up 1. So 2 plus 1 is 3. 0 plus 1 is 1. What's negative 2 plus 1? Negative 1. 1 plus 0, 1. And 2 plus 1, 3. There's my pattern. So I'm going to say 3, 1, negative 1, 1, 3. There's my graph. And did my midline change?
Yeah.
Yeah. it went from y equals 0, I added 1, the 2 does not affect it, so I am now at y equals 1. And if I look here, isn't it going down 2 here and up 2 here? Isn't that my midline? Another way to find your midline, if you get confused, sometimes it looks a little strange when it's not sitting around an axis, just count 1, 2, 3, 4, and take half of it, 2. Either go down 2 or up 2, and you hit your midline. It's halfway through, right? All our midlines are always halfway through our graphs. Okay, and one more we have to do. One more. If you want, you can do it down here because I didn't give you tangent, right? I said don't do the tangent. So why don't we do this one? You can do yours down here, make it easier, and I'll do mine on this clean space. We're going to do this sine one. So what's the amplitude for the sine curve? 2. What's the frequency?
0.5.
Good. It's 1/2. This means we're making 1/2 of the curve in 2 pi. So if I make 1/2 of my curve in 2 pi, how long does it complete?
4 pi.
4 pi. And doesn't this make sense? 4 pi over 1/2, keep change flip, 4 pi. And again, take your period, divide it by 4. This gives you your quadrants. So what is 4 pi divided by 4? Pi. So here's my marks. Every pi, I have to make one. And my period for sine is 0, 1, 0, -1, 0. And I'm going to amplify that by 2. So what should I do?
Go up to 2.
No. Multiply by 2. So that's what you meant by go up?
Yeah.
Okay, I thought you meant, right. So we're going to multiply this by 2. And we're just going to follow that now. 0. So then we come over here and we're up at 2. Then we come back down here, we're back at the 0. Isn't this half of my curve? Now if I had another graph sitting right here, I could continue it and come up and do the other half in the other 2 pi, right? So does this make more sense? Okay. I'm big on graphing without the calculator. Graphing